Hey there, this is Sid and today we shall solve a SQL problem from StrataScratch. The title of the problem is the most popular client ID among users using video and voice calls. As always, we shall start off by having a look at the input table. We have exported the input table to Microsoft Excel where it's easiest to view. Once we have gone through the input table, we shall come back to the problem statement. So here's the input table. The input table records events performed by users using different clients. So the first column is the ID column. It uniquely identifies each row of the table. The second column is the time ID column. It displays the date when the event happened. The third ID is the user ID. It is the ID of the user who performed the event. The next column is the customer ID. It lists the company through which the user performed the event. Then we have the client ID. The client ID is the type of device using which the user performed the event. It may be one of two, either a mobile or a desktop. Then we have the event type and finally the event ID. The event type is the type of the event. For example, it may be message sent, file received, video call received, and so on. And the event ID is a unique integer that is assigned to each event type. For example, message sent has an event type of 3, file received has an event type of 2, and so on. For the purposes of this problem, we shall mostly be concerned with the user ID, the client ID, and the event type. Let's now go back to the problem statement. So the problem says that select the most popular client ID. That is, the answer would be either a desktop or a mobile, based on a count of the number of users who have at least 50% of their events from the following list. So they are asking to output the most popular client ID, but not based on the entire table, based on only those users who have at least 50% of their events from the following list: video call received, video call sent, voice call received, and voice call sent. So first we have to take this entire table and then filter out to keep only those records for which the user, the column C in this case, has performed events where more than 50% of the events belong to one of those 4 categories. So there would be many users who, for example, might have performed several events, but not the majority of those events were performed using any of these. So the records for those users would have to be removed before we make any subsequent computation. So I believe that the problem statement is clear. If it is still not clear, I am sure it will become clearer as we go through the problem. So the first thing is to find out those users for whom more than 50% of the events belong to one of these 4. The way we do that is first by assigning a unique numerical code, either a 0 or a 1, to each of the possible event types. So we have taken all the unique events from this column, the event type column, column F, and since there may be some events which never occurred but can potentially occur, we have also taken the events from this list in case they are not already present in the column F and come up with this list of unique events. Now each of these events have been assigned either a 0 or a 1 based on whether they belong to this list of 4 events or not. If they belong to this list of 4 events, then the event class is 1. If they do not, then the event class is 0. So this is our event class lookup table. Next, what we have done is we have taken the user ID, the client ID, and the event type columns from the fact events table and come up with this intermediate table 1. This intermediate table 1 contains an additional column called event class. So for each record, the event type has been looked up from this event lookup table and the corresponding event class has been assigned to the column L. So for example, message sent has a value of 0 in the event lookup table. So in the event class table, we have a value of 0 here. Why we generate an event class table in this way will be clear in a moment. But I hope that as it stands, the intermediate table 1 is perfectly clear now. Next, we have a pivot table here. So what this pivot table does is, in the column O, which is called the row labels, we have the unique IDs of all the users. So this column O is essentially the unique user IDs. That is the column C in the original fact underscore events table, or this column in the intermediate table 1. So the unique of those user IDs are present in this column here, the column O or the row labels column. Then for each user ID, we have performed 2 calculations. One is the count of the event class, that is the total number of times that particular user appears in the fact underscore events table. That is this number, the column Q. This is the total number of occurrences of this particular user ID in the fact underscore events table. This intermediate column, the sum of event class is the number of events which belong to one of those four classes: video call received, voice call received, video call sent, and voice call sent. So now I think the reason for introducing this event class column is clear. It makes performing this simple arithmetic very easy. To find the total number of rows on which a particular user ID appears, you simply take a count of all the events. So count includes both event class 0 as well as event class 1. So this will give you the total number of times this particular user ID appears in the fact underscore events table. The sum of the event class will only count the number of times a particular user ID appears in the fact underscore events table where the event type belongs to one of the four events that was listed in the question. Why so? Because when you take a sum of a sequence of numbers, each of which is either a 0 or a 1, only the ones will contribute, the zeros will not. So this number gives us the number of events for this particular user ID which belongs to one of these four classes. A bit lengthy explanation, but I think it is straightforward. Next, we have taken this pivot table and pasted it here as a normal table. There is no other reason for doing that apart from the fact that it's easier to work with a normal table than a pivot table when you are trying to make extra calculations. I have made a slight change of nomenclature here. The events that belong to one of the four events that was mentioned in this problem statement, I have chosen to call that good event, and the total event is the total number of events. So for example, for this user, which corresponds to this row here, the number of good events is 0, the total number of events is 5. So the fraction of good events to the total number of events is 0.00. This is 0 by 5. And I have done that for all the other users. And having done that, I simply eyeball through this column or apply a filter on the good underscore fraction column to find out the users for which this fraction is greater than or equal to 0.5. After that, we find that there are only two such users, the users that I have highlighted in green color. So up to this point, we have been able to filter out those user IDs for which a certain class of events contribute to more than 50% of all the events for those users. In other words, this part of the problem of users who have at least 50% of the events in the following list. So this part of the problem has been solved. And the output of that part is just these two users. So once we have had those two users available, I go back to my original fact underscore events table and apply a filter on the user ID column to keep only those users which are highlighted in green here, namely these two users. And that filter table is available here. Again, I have kept only the three columns: user ID, client ID, and event type. Now we are just one step away from the final solution. All I have to do is I have to take a count of each of the possible client types. So if I just look at this table or do a pivot table as I have done below here, I find that desktop appears in 11 cases and mobile appears in 3 cases. So desktop is the clear winner and the final answer is desktop, as you can see in the expected output here. So I hope that you now understand the solution to the problem in Excel. Now let's try to translate this solution to SQL. As always, I have written the SQL query in Notepad++ because that's why it's easiest to see. The solution consists of a sequence of CTEs and finally a SQL query on the last CTE. The first CTE is called good underscore events underscore fraction. As you can infer from the name, the goal of this CTE is to come up with a table like this. What is the fraction of good events for each of the users? So obviously there has to be a user ID in the select clause and there has to be a grouping by the user ID, because after all we are rolling up the data to the user ID level. The second column is the aggregate column. It may look a little convoluted, but it's easy. Let's first look at the denominator of this second term, the aggregate column. The denominator is the count of the event types. So you could have used any other column here, does not really matter. This denominator basically gives the total number of times each of the user IDs appears in the fact underscore events table. So that's clear. Now for the numerator, we want for each of the users the count of events that belong to one of these four events. So the way to do it is we have to somehow come up with a column analogous to this column of the Excel file. There should be zeros and ones assigned to each record. And that is done by using a case when statement. So we are saying that, okay, look at the event type column and see if the value is one of these four. If it is, then assign a number 1, and if it isn't, then assign a number 0. So that will generate that new column, and then you apply the sum function on that newly generated column. That will give you the count of events that belong to one of these four classes. And finally, I have multiplied by 1.0 to ensure that the entire arithmetic is float. Let us quickly copy this CTE and run it in the SQL editor. When we do that, we see that in the output for each user ID, we have the good event fraction. So this user ID has a good event fraction of 0.09, the next one has 0.05, and so on. This is exactly analogous to this table in our Excel based solution. Going back to the SQL query, now we have to find out the users for which that fraction was greater than or equal to 0.5. I call those chosen underscore users. So if I copy this part of the SQL query and run it in the SQL editor, this is our output. As you can see, only 2 users survive, and they are the same users as we had in the Excel based solution to the problem. Going back to the SQL query, now we need the client counts. So now that we have the list of users who should be kept in the final computation, all we have to do is find out the count of each client type. That is the number of times desktop appears and the number of times mobile appears from the original fact underscore events table. But this time we apply an extra filter condition on user ID. The user ID must be one of those 2 users whom we call chosen users. So running the highlighted SQL query in the editor, we see that the output looks like this. Desktop appeared 11 times and mobile appeared thrice, which agrees with the Excel solution again. If you recall, this was our Excel solution. So now we are almost there at the final solution. The only step that is left is we have to rank the clients. Now to do this, you could either have simply ordered this output by the count column and kept the first one. But just imagine for a moment that instead of 2 clients, you had more than 2, say desktop, mobile, smartwatch, tab, and laptop. In that case, there is a possibility that the topmost count will be tied between more than one client. So let's say desktop got 11, laptop also got 11, and then mobile, etc., they got less than 11. So you'd like to return both desktop and laptop for that case, right? So for that purpose, we have used this CT. So this basically assigns a rank to each of the rows based on the descending order of counts. You would actually get the same result even if you use the rank. So it's not necessary to use dense rank here. And this rank column is assigned an alias drnk, dense rank. So in the final output, we simply say, give me all the client IDs, not the entire records, for which the dense rank is 1. So if I select this entire query and run it in the SQL editor, the output that we see is desktop, which of course agrees with the output provided by StrataScratch. I do hope that you have been able to understand the solution that we have provided here. I'll keep coming back with more solutions to SQL problems from StrataScratch. Please stay tuned.